Hi friends, welcome. Today we're going to solve binary search tree iterator problem on Leetcode. This is a medium level problem. Let's get into it. So the problem statement is to implement an iterator over a binary search tree. The iterator will be initialized with the root, calling the next method on the iterator will return the next smallest number in the binary search tree. Calling the has next will return a boolean which lets us know if there exists a next smallest element in the binary search tree. There are a couple of conditions as well. The next and has next method should be constant time and can use only O of h memory, where h is the height of the tree. Let's see how to solve this problem. So this is an example binary search tree, and in the problem we are given the root node, which is 7. So the approach to solve this problem is to consider a stack. Since we want to have constant time for next and has next, the idea is to use a stack and use the pop and peak methods to return in O of 1 time. So how do we achieve that? So whenever we're looking at a root, the idea is to traverse to the left of the tree as much left as you can go and start adding all the elements during that traversal to the stack. So in this case, with taking the root, if we start the traversal going left and adding all the elements to the left to the stack will look like this. So we will add 7 to the stack, and then we go to the left and we add 3. So this is the current state of the stack when we are at 3. Cool, that's good. So what about the right elements? Since when we go to the left, this is the smallest element in the binary search tree, when someone calls the next method, we pick 3 from the stack, so we return 3. But before returning 3, we need to see if 3 has a right. Since 3 has a right, we need to add that to the stack. So in this case, we add, when we pop 3, we put 4 in the stack, and once we take out 4, we will have 7, and when we are taking out when we are taking out 7, since it has a right, we add 15, and we have to keep going left. So this is what our stack will look like during those traversals. Okay, let me clean this up a little, and then we can jump into coding this. Okay, that's our tree. Let's try to code this problem. Okay, for this we have to initialize a stack. So let's take a stack tree node, and then initialize it in the constructor. Cool. To fill all the leftmost elements, in this case to fill all the leftmost elements, we need to have a method. Let's call it fill, and let's pass it a node. You can just call it node here. While node is not null, the idea is to push that node to the stack, but also push all the leftmost elements to this stack. So this method basically puts both 7 and 3 in the stack when we are running it on the root. So let's do that. So at this point we have 3 and 7 in the node. Let's implement the easiest method. So has next is just checking if the stack is empty, just making sure that the stack is not empty if it has a next. For the next, let's pop the first item from the stack. So in this case we've looked at the stack, we have 3 and 7. So when we pop, we have the tree node 3. When we have 3, what we have to do is fill the stack with any elements that exist to the right of the current node that we just popped. So in this case, if it has 4, we call the fill method, which basically looks for any leftmost of the right element to fill to the stack. So in this case, when we run this method, it will be putting 4 in the stack. Since we don't have any left for 4, it only puts 4 in the stack. So this will be the current state of the stack right now when we do the fill. And after that, we just return the value of 3, which is what we popped from the stack. Okay, let's run this code. That's a success. That's all, friends. Hope you understood the problem and it was clear. If not, please leave a comment and I can explain. And thank you for watching the video. Subscribe if you